Hello friends, in this video we are going to study about the various components of a microprocessor. The various components of a microprocessor are the arithmetic and the logic unit, memory, input devices, output devices, and we have control unit, register array. These are the various components of a microprocessor. Because as we have said that the microprocessor, it is a programmable device, so there should be some memory to store the program and the instructions, and we have the microprocessor, it is performing different types of operations, so there should be some arithmetic and logical unit for performing these operations. Also there should be some registers to store and hold the result of the operations, and there should be some input and output devices are there. So let's draw the block diagram of this components of the microprocessor. Now the microprocessor, it is having three parts. First is the arithmetic and the logical unit. Also known as ALU. The second part is the register array. And third part is the control unit. So this is the inside of the microprocessor. Now as we have that the microprocessor, it is getting some input and it is producing the result as the output. So here we also have the peripherals, or we can say input and output devices. These input and output devices, they are also known as peripherals. Also this microprocessor, it is having a memory. This memory, it is of two types, RAM and ROM. Just like in computers, we have read-only memory and read-access memory. Okay, so this microprocessor, it is getting the input from the microprocessor and using the instructions or the program written in the memory and performing the arithmetic and the logical operations over the data, and control signals, they are used to execute the instructions, and then it is producing the result as the output. So the communication link between, there has to be some communication link between the microprocessor, peripherals and the memory. So here we have buses for that. These are the buses which are acting as a communication link between the memory, microprocessor, peripheral and the outside world. So this block diagram shows us the various components of the microprocessor. Let us study one of these components one by one. So first we will start with the arithmetic and the logical unit. The function of this component ALU, it is just like its use in the computers. In computers, the ALU unit, it performs the arithmetic and logical operations. Here also the function is same. In microprocessor also, the ALU unit, it is going to perform the arithmetic and logical operations on the binary data which the microprocessor it is getting as an input. The next component was register array. The register array, it is used to hold or store the intermediate data or the intermediate results when certain operations are going on. Suppose there are 10 instructions written in the program, and there after the execution of 4 instructions, some data has been produced or some output or result has been produced which has to be used in the further instructions or in the remaining program. So that intermediate result, it is going to be stored in some registers in the register array. So it is the function of these register array. It is used to store So register array, it is used to store the data temporarily during the execution of the program, and these register array, they are accessible to the user through instructions. The user can also use these register array, and it can also see that what is the intermediate result or what data has been stored in the register array. Now the next component is control unit. Now, as the microprocessor, it is performing the operations according to the instructions written in the program. So the execution of each instructions, that how the microprocessor it is going to understand that now this time I have to execute this instruction, next I have to execute this instructions. So the procedure should be there to control the execution of the instructions. So this control unit, it provides the controlling and the timing signals to the microprocessor, so that microprocessor can easily execute the instructions and smoothly it can perform all the operations on the data. So control unit, it is providing the necessary timing and control signals to all the operations, and it controls the flow of data between the microprocessor, it is the short form of the microprocessor, and the peripherals and the memory. So it is controlling that how the data is going to be flow, or like where the microprocessor, from where it is going to pick the data and where it is going to store the result, how it is going to display the result, where it is giving on which output device it has to show the result. So all this is controlled by the control unit. Now next we have memory. The next component of the microprocessor is memory. Memory is the storage device. It is the storing the instructions, the input, the output, intermediate results, everything it is stored in memory. That is why it is called a storage device. So what is the function of the memory? It is storing the binary information such as the data, and it is providing that information to the microprocessor whenever it is necessary. So the input which the user is providing to the microprocessor, it is getting stored in the memory. Now whenever the microprocessor wants to read that data or wants to execute the operation on that data, so the memory will provide it that data to the microprocessor. Now to execute the program it is written in the memory of the microprocessor. Now the microprocessor is executing the program. So for execution, the microprocessor, it will read the instructions one by one. It is going to execute each instruction. If we want the input, then input it will read from the memory, and the result of that program or the instructions, again it is going to store it in the memory. So when the microprocessor it is executing the program, it will read the instructions and the data from the memory, and then it will perform the arithmetic and logical operations on that data in the ALU unit. After that, the result of the operations, it is either transferred to the output devices for display so that the user can read the result of the operation, or either it is stored in the memory so that it can be used in later programs. So in this way the memory is being used in the microprocessor. Now this memory, it is of two types, RAM and ROM. Just like in computers we have, it is of two types, RAM and ROM. This is random access memory and this is read only memory. Now, what are the uses of the RAM and ROM? RAM is the user memory, whereas ROM, it is used to store the programs that do not need changes. That is, at the time of manufacturing of the microprocessor, the read-only memory, in that read-only memory, the programs which have been used by the microprocessor for its functioning, those programs are stored in the ROM memory, that is read-only memories. So these programs, they do not need changes and they cannot be altered. No changes can be made by the user in these programs. Whereas in the random access memory, because it is the user memory, so the programs, they can be stored in it and also changes can be made in that. So these are the two types of memory present in the microprocessor. Next, comes the peripherals, that is the input output devices of a microprocessor. First we have the input devices. Now what the input devices are doing, they are giving the input or the data to the microprocessor, and output devices, they are displaying the result so that the user can read it through the output devices. So input devices, they are providing or transferring the binary information from the outside world to the microprocessor. Now various examples of input devices are keyboard, switches, etc. Now output devices, output devices are transferring the data from the microprocessor to the outside world. That is, they are providing the result. And examples are, we have monitor, we have LED, CRT, video screen is also there, printers, etc. These are the examples of the output devices, and combinedly the input and the output devices, they are known as the peripheral devices. Now we have studied the various components like ALU, register array, control unit, memory and peripheral devices, and the communication link between these components, that how the data is going to flow from one component to the other component, it is provided by the bus. So the bus is the communication link between the various components. So we can say that the bus is a group of wires or lines that carry similar information. Now this bus, it is of three types. We have first as system bus, then address bus, and data bus. Let us study these three types of buses. First we will have system bus. System bus is a group of wires or lines which is used for the communication between the microprocessor and the peripherals. Whenever the microprocessor it want to read the data, it wants to get the input from the input devices, and if you want to get the result or give the result on the output devices, then the system bus is used for that flow of data. Then we have the address bus and the data bus. So address bus, it carries the address, which is a unique binary pattern used to identify a memory location. Now the memory location, there we have the array of registers. Suppose this is a memory location. if the microprocessor it wants to read the data from the microprocessor, so where the data is stored, so each memory location it will have a unique address. Suppose this is memory location number 1, 2, 3, 4, 5, so on. We have different types of memory location, so each memory location will have a unique address. So this address bus it will carry that address, so that the microprocessor it can identify a memory location and it can pick up the data from that memory location. Similarly, the input and the output ports on the microprocessor, they also have the addresses. So whenever the microprocessor it has to pick the data directly from an input device, so it will give that address to that input device. It has that memory location, so it can easily pick the data from that input device, or it can display the output to a specific output device also. So the memory location and input output devices, they have unique address, and this address is carried or it is given to the microprocessor through this address bus. Next we have the data bus. Data bus it is used to provide or transfer the data between the memory and the processor, or between the input output device and the processor. If the microprocessor it wants for the execution of the program, it needs some data, and that data it is stored in the memory location. So it will get the address from the address bus, and from that address bus it will pick the data, and that data will be provided to the microprocessor by the data bus. So let's take an example so that you can understand that what the address bus and the data bus is doing. Like for example, we have an 8-bit address bus. 8-bit address bus means it has 8 lines to carry the address. If we want to check the addresses range that it can address, we will have 2 raised to the power 8. It is equal to 256. Because it has 8-bit address bus, we have 8 lines, so we can have we have 2 raised to the power 8 combinations of that 8 bits, and it comes to be 256. So we have 256 memory locations that can be addressed using this 8-bit address bus. Because this 8 bits, let's take an example, we can have 0, 0, 1, 0 and 1, 1, 0, 1. These are the 8 bits. Just like this, it is a combination of 0 and 1. So these 8 bits can have 256 combinations, and these 256 combinations can be used to address 256 memory locations. So we can have here 0, 0, starting from 0, 0, it is in hexadecimal, till FF. It is also in hexadecimal location. So starting from 0, 0 to FF, these 256 memory locations, they can be addressed using this 8-bit address bus. Now comes the data bus. So data bus, it can also be 8-bit or 16-bit or 32-bit data bus. Similarly here, like we have 8-bit data bus. It means that the microprocessor it can handle 8-bit data. And we have said that the microprocessor, it is defined according to the data it is getting as an input. So if it has 8-bit data bus handling 8-bit data, so that microprocessor will be an 8-bit microprocessor. Similarly, we have 16, if the microprocessor is having 16-bit data bus, it will deal with 16-bit data, and it will be called a 16-bit microprocessor. So this is the bits, how much bits of data the microprocessor it is getting as an input. So this was about the buses of the microprocessor. So the microprocessor, we have studied that it has various components: the arithmetic logical unit, control unit, register array we have studied, memory we have studied, and the buses, which are the communication link between the various components, that also we have studied. So this was all about the microprocessor components. So we can say that how the microprocessor it is working. It is getting the input from the input devices, then it is performing various operations on it according in the arithmetic and the logical unit, getting the data from the input devices, and then it is producing the results. If there is an intermediate result, then it will be stored in the register array. The control unit, it will provide it the controlling and the timing signals, and the result it will be displayed on the output devices. So let's first study the working of the microprocessor, that how the microprocessor is working. So how a microprocessor works. As the microprocessor, it is a programmable device. So we have programs. In the programs, we have the instructions, and according to that instructions, the microprocessor performs various operations. So the first task of the microprocessor will be to read the instructions. The instructions, they are sequentially stored in the memory. The programmer, it is going to make a program, and that program it is going to stored in the memory, and the microprocessor, when it is going to run the program, then it will read the instructions one by one. So first it will fetch the first instruction. So suppose certain instructions are written, a program is written having suppose 10 instructions. So the microprocessor first, it will fetch the first instruction written in the program, and then it will decode it, because the programs, they are written in various types of languages, like we have machine language, assembly language, then we have mnemonics. So the microprocessor, it is going to decode that instruction, that what that instruction is defining, what operation it has to perform, and then it will execute that instruction. Suppose addition is given to it, so the microprocessor, it will read the instruction. If that instruction said that it has to perform the addition of two numbers, then it is decoding it and then executing the addition operation on that two numbers. So this is how the microprocessor, it performs or it executes each of the instructions. So this cycle of fetching, decoding and executing the instruction, it will go on till the program it has ended up, or the microprocessor, it has reached to the last instruction of the program, showing that the program has been ended up, and now the microprocessor has to give the result of the program. So the sequence of the fetch, decode and execute, it is continued till the microprocessor it comes across an instruction to stop the cycle or to stop its function. Now it has to end up the operation and it has to give the result to the user. So during this process of fetching, decoding and executing the instruction, the microprocessor it is using the data. So this data is provided to the microprocessor by the buses, and all the data, results, all the things they are passed from the microprocessor to the memory and the input output devices through these buses. Now the data it is fetched from the memory and from the memory using this system bus, and then it is provided to the arithmetic and logical unit to perform the operations. Now if there is any intermediate result, then the microprocessor it uses the registers to store the temporary result. And then the result of the operation it will provide on the output devices. And then it will display the result using the same bus lines to the 7 segment display, or we can say that the output section. So this is how the microprocessor it works. We are giving it a program, then the microprocessor it is going to fetch the first instruction, going to decode it and then execute that instruction. Then it will fetch the second instruction, decode it and then execute that instruction. Similarly, it is going to execute all the instructions up till it is going to get a instruction which is showing it that it has to stop the programming, it has to stop the program and then it has to display the result on the output devices. So this is the working of the microprocessor. Now in its working, you have studied that the microprocessor deals with the binary data, that data which is in the form of binary numbers 0 and 1. So and also instructions has to be written in the microprocessor. So the programmer which is dealing with the microprocessor, it should have the knowledge of the instructions of the microprocessor. It should be able to write the program. He or she should be able to write the programs for the microprocessor. So the knowledge of the instruction set of a microprocessor, it is necessary for a programmer. Now the programming it is done in various languages. First we have machine language. The machine language it is in the form of zeros and ones. And this language of zeros and ones, it is not understandable by the user. Then we have the assembly language. Assembly language is the language in which the user writes the program. And this language, assembly language, it uses a code for each instruction, and this code is known as mnemonics. So we can say that the user should have, if he wants to use the microprocessor for a certain application, then it should be able to have the knowledge of the instruction set. It should be he or she should be able to write the program using the mnemonics, so that it can easily use the microprocessor for different types of application. So we have programmer should be able So programmer must have idea about the internal resources of the microprocessor, its features and supported instructions, so that the programmer can write the programs for whatever application he wants to use the microprocessor. So in this video we have studied about the various components of the microprocessor and how the microprocessor works. So I hope this video is clear to you. Thank you.